Alright, in this video we're going to be looking at a heating curve, and we're going to look at all the information that a heating curve can tell us. So this first picture I have here on the screen is a heating curve, and it just says a sample. So we don't know what this is a heating curve of. Okay, let's look at our axis here. We've got temperature in degrees Celsius, and the x-axis is time. So this is just as we increase temperature, how much time it takes to go from one step to the next. So let's look at our very first line. This is where a solid would be. So let's just say we start with a solid chunk of this sample, and then it takes 2 minutes, and we increase the temperature up to 50 degrees Celsius, and then notice this flat part. Right after being a solid, when you're adding heat, you're going to start to melt. So this is where melting occurs on this flat part, and it melts, and once it reaches this point right here, it's turned into a liquid. So from here to here, you have a solid and a liquid existing at the same time. This is where it's completely liquid, and it continues up, and it heats, and it reaches this point right here, and it starts to turn into a gas. So this is where we have evaporation occurring, and again, you're gonna have it existing as a liquid and a gas at the same time. Okay, now what if we start, this graph is reversible, so we could start at the top of the graph up here and go backwards. So we can go from a gas, reach this point, and it starts to turn into a liquid, and that would be condensing. Okay, and after it condenses, it turns into a liquid, and as we decrease temperature here, we hit this point, and it starts turning into a solid, and that would be freezing. Sublimation and deposition are not on here. Okay, so the next thing we can get from this is we can get the melting point, we can get the freezing point, and we can get the boiling point. So the melting point is the temperature in which melting occurs. Notice that that is a flat line. It's not changing temperature as it melts. So in order to go from a solid to a liquid, it stays the same temperature consistently, and that point is 50 degrees Celsius. The freezing point is from a liquid to a solid, and again, that's a flat line. It doesn't increase temperature, and it happens at 50 degrees Celsius. And the boiling point is up here, and again, a flat line, and that would be 110 degrees Celsius. So no temperature change during phase changes. What you will notice is that it does take time. So from here to here, it took time, which is going to relate to energy. The more time something takes to do it, the more energy that it took. Okay? Let's take a look here. It took from 2 minutes to 5 minutes to melt, and it took from 10 minutes, 14 minutes to evaporate. So this one was a total of 3 minutes. This one was a total of 4 minutes. So when you're thinking about this, you can think about which one of these do you think takes more energy to do. If it only took 3 minutes to melt here, and it took 4 minutes to melt here, it takes more energy to turn from a liquid to a gas than it does from a solid to a liquid. Okay, let's look at one more graph down here. This is a little bit different. This is, again, we have temperature over here, and that stayed the same. But down here we have heat, and heat is going to be heat energy. So now this graph is focusing a little bit more on that energy aspect of it. So from 1 to 2, that's where you have a solid. Okay. And what's happening is you have a temperature increase. From 2 to 3, you have melting. Or if you're going in the opposite direction, you have freezing. And 3 to 4 is your liquid. And you have a temperature increase again. And 4 to 5 is evaporation or condensation. No temperature increase. And 5 to 6 is where your gas happens. Okay, so that's that labeled. Now, one more thing we can look at here, which is actually very interesting, is when do endothermic processes happen? And when do exothermic processes happen? So endothermic means energy is absorbed. So when we're talking about which direction our process is endothermic, it takes energy to move from a solid to a liquid to a gas. So if we're moving in this direction, those are going to be endothermic processes. And in endothermic processes, your energy, or your change in enthalpy, is a positive value. You gained energy. Exothermic energy is released. Okay, and it's going to be exothermic as you move in this direction on the graph. And that's going to be a negative value. So these are all the things you can get from there. So melting, that's endothermic. Freezing, that's exothermic. Evaporation is endothermic. And condensation is exothermic. And that's about what you can get from a heating curve. Now the next video we're going to be looking at things, how to calculate from this heating curve.